This is a Hass avocado. This is a Hass avocado seed. And if you plant this Hass avocado seed, it will not give you a tree that produces Hass avocados. This Walden seed will not give you a tree that produces Walden avocados. This seed from a Hull avocado will not grow a tree that gives Hull fruit. And by now, the pattern is clear. The seed from a Monroe avocado will not give you a tree that grows Monroe avocados. In fact, that is true for every variety of avocado and every one of these seeds. Because avocados do not grow true to seed. And once you understand why, you will never look at that pit sitting on your kitchen counter the same way again. So what does it mean to grow true to seed? Growing true, or true from seed, or true to seed, means that when you plant the seed from a piece of fruit, the resulting tree will produce fruit identical to the fruit you ate. Or if not identical, very, very similar. Peaches, for example, grow true to seed. So if you eat a peach and take the pit and plant it in the ground, about 10 to 12 years later, you will have a tree that produces peaches that taste just like the one you ate. Certain types of citrus also grow true to seed, such as key limes or grapefruit. If you eat a key lime and plant some seeds from it, the resulting trees will give you key limes that taste exactly like the one that gave you the seeds in the first place. With avocados, on the other hand, if you save that seed and plant it in soil, you will get an avocado tree. And that avocado tree eventually will produce fruit, but that fruit will not taste anything like the fruit from which the seed came. In fact, it is statistically unlikely that the fruit will even taste good at all. Now, a lot of folks from up north will know exactly what this means when the word crabapple comes up. Apples, like avocados, do not grow true to seed, and the crabapple tree is what happens when someone plants an apple seed expecting to get delicious apples and ends up with something entirely different. These trees were everywhere in certain neighborhoods. The fruit looked gnarly. It was inedible. The apples would fall on the ground and rot. They made the sidewalks slippery. They made the road slippery. They were actually a traffic hazard. And when they started to rot on the roads and sidewalks, they stunk. They reeked. The apples were full of worms. They were just a mess. And the question that comes up is, why would someone plant a crabapple tree? Why not plant an apple tree that gives good tasting fruit? Well, the answer is simple. They did not understand that apples do not grow true from seed. So they ate an apple. They saved the seeds. They planted those seeds. They germinated a little seedling. They went out in the yard, planted their apple tree with the hopes of having some nice, juicy apples in a few years. And what resulted instead was a crabapple tree with fruit even the squirrels turned their noses up at. Here's where the numbers tell the story. They estimate that for every 80,000 apple trees grown from seed, you will get one tree that produces good-tasting fruit. 1 in 80,000. So those Macintosh apples you love, or those Granny Smiths, or those Golden Delicious, they were 1 in 80,000 anomalies. Someone got lucky. And for avocados, that rate is about 1 in 10,000. So 9,999 avocado trees produce yucky fruit until one lucky winner pops out. Someone tastes it, says that tastes good, lets other people taste it, those other people agree, and if the tree produces a consistent yield, they patent it and give it a name. That is how Hull came to be. That is how Monroe came to be. That is how every named avocado variety you have ever seen at the grocery store came to exist. They were the rare winners in a genetic lottery where almost everyone loses. And then there is the Hass. The Hass tree was actually planted from seed by a man named Rudolph Hass. He tried to graft onto that seedling, but the graft failed. So he just let the tree grow from seed anyway, and the resulting fruit was something special. But here's the twist. He wanted to cut the tree down. He saw it as a failed experiment. But his daughter loved the taste of that avocado so much that she convinced him to keep the tree. Other people tasted the fruit. They liked it too. So Rudolf Haas patented it. He sold the patent for $5,000. And to this day, 4 billion of these are eaten every single year. It is a $2 billion industry, all because a daughter talked her father out of cutting down a tree. If you are finding this useful, take a second to subscribe. There is more to cover here, and it only gets more interesting from this point. So why does this happen? Why will that Hass seed never give you a Hass tree? Let us use candy to explain. Imagine that one avocado tree produces fruit that tastes like Skittles. Another tree produces fruit that tastes like caramel, candy. And a third tree produces fruit that tastes like wintergreen lifesavers. Each of those flavors on its own might be appealing. Skittles, delicious. Caramel, delicious. Wintergreen, also delicious. So, somewhere along the line, 10,000 trees were planted, and one of them produced avocados that tasted like Skittles. People loved them. They named it the Skittle Avocado. Same thing for the caramel tree. Same thing for the wintergreen tree. Now, eventually, someone eats a wintergreen avocado. They love it. They save the seed. They plant that seed. 10 years later, they have a mature avocado tree. That tree produces fruit, and even the squirrels will not eat it. They take a couple of bites and walk away. Why? Because the fruit tastes disgusting. Because just like human beings, that seed had to be created from 2 sets of DNA. It had to be created with pollen from a male flower, which pollinated a female flower, which means the seed contains the attributes of a father tree and a mother tree. In this case, maybe the father tree was the one that gives you caramel, and the mother tree was the one that gives you wintergreen. Caramel on its own, delicious. Wintergreen on its own, delicious. Wintergreen flavored caramel? Not so much. Avocado trees are a lot like humans in this way. You have some of the attributes of your father, some of the attributes of your mother, but you are not an identical clone of either. And furthermore, you are not an identical clone of your siblings. So not only will each of these seeds fail to grow a tree identical to the mother tree, every single one of these seeds will grow a genetically unique organism that has never existed before. You will wind up with fruit that tastes like wintergreen flavored caramel, or caramel flavored wintergreen, or wintergreen flavored caramel with a hint of Skittles. The combinations are unpredictable, and most of them are not combinations anyone wants to eat. But maybe you are feeling lucky. Maybe you want to roll the dice. Remember, 1 in 10,000 times, something magical happens. Imagine you have a tree that gives you avocados that taste like peanut butter. And not too far away, there is another tree that gives you avocados that taste like chocolate. One day, a honeybee goes out and collects pollen from the male flowers of the peanut butter tree. That bee flies over to the female flowers of the chocolate tree. The pollen meets the flower. They combine their DNA to produce a seed. You plant that seed, you grow a tree. And that tree gives you a piece of fruit that combines the chocolate from the mother and the peanut butter from the father. If that happens, congratulations. You have just created a Reese's Peanut Butter Cup avocado. You hit the 1 in 10,000 lottery. But those are long odds, and most people do not want to wait 10 years to find out they lost. So, how do growers get around this problem? Grafting. A grafted avocado tree starts with a seed. That seed is planted, and it grows a little trunk, a rootstock. Then, that trunk is clipped, and a cutting from a known variety, a tree out in a grove that produces the exact fruit you want, is taken and inserted into that clipped trunk. At that point, the tree that was planted from seed stops growing upward. It still grows roots underground, providing the foundation, but the cutting from the donor tree continues to grow upward. So now you have a seedling rootstock that would have given you one of those unpredictable mutt blends if left alone. But inserted into it is a pure genetic copy of whatever variety you wanted. If you want avocados that taste like Skittles, you go out to the grove, take a clipping from the tree that gives Skittles, stick it into a seedling rootstock, and in about 3 to 4 years, you get avocados that taste like Skittles. Every single time. No lottery, no guessing, no waiting a decade to be disappointed. So what is the takeaway here? If you have ever saved an avocado pit with plans to grow your own Hass tree, the intention makes complete sense. It is logical to expect that if you eat a piece of fruit and it gives you a seed, planting that seed will give you more of that fruit. That is how it works with peaches. That is how it works with key limes. But with avocados, it simply does not work that way. The seed in your hand carries the DNA of two parent trees, and the fruit it eventually produces will be an unpredictable combination of both. Maybe edible, probably not. Almost certainly nothing like what you were hoping for. If you want a tree that produces a specific variety, grafting is the answer. And if you do not want to do the grafting yourself, buying a tree that has already been grafted is the simplest path to fruit you will actually want to eat. So that is why a Hass avocado seed will never give you a real Hass avocado tree. Thanks for sticking with this one all the way through. If this cleared up something you have been wondering about, or if it saved you from a 10-year disappointment, hit subscribe and the bell so you catch the next one. And if you have already planted a seed and watched it grow, drop a comment and let us know what happened. See you on the next video.